Okay, so now we're going to look at some set theory and set past paper questions. And as always, if you'd like to try out some of these problems by yourself before I walk through the solutions, please go ahead and give them a shot. Let's go straight in to question 1. Okay, the Venn diagram above represents the universal set E of all teachers in a college. The sets C, B, and P represent teachers who teach chemistry, biology, and physics respectively. Now it asks us to sketch the diagram twice, and I've gone ahead and done that for you guys. On the first diagram, shade the region which represents those teachers who teach physics and chemistry but not biology. Let's underline the keywords first. So physics and chemistry but not biology. So one thing you want to consider here for sure is this word and. If it said physics or chemistry, that could mean this whole region here, right? Because you could be a physics teacher or a chemistry teacher or both. But if it's physics and chemistry, then we're looking only at this intersection region here. So initially we want to look at this region here, but however, it's also telling us physics and chemistry but not biology, right? So we want to ignore this biology set here. And if we ignore that, that means we can't use this section here. What does that leave us? Well, that leaves us this small area here, and that will be our answer. Okay, let's go to the next question. On the second diagram, shade the region which represents those teachers who teach either biology or chemistry or both, but not physics. Okay, not physics. Once again, we can then ignore this whole physics set. And if you're doing this on paper, one way I like to do this is I either use my fist or my thumb or a few of my fingers and just physically just put them over this circle here. So kind of block them from my vision. And it really helps me to visualize the set I'm looking for. So over here, we're looking for either biology or chemistry or both, but not physics. So if we're looking for either biology or chemistry or both, that means we're looking at this whole union region here, right? You can be a chemistry teacher or a biology teacher or both. But then since you can't be a physics teacher, we're excluding anything which intersects with set P, which means we're looking at this bit, aren't we? Right? Since I can be a chemistry teacher or a biology teacher or both, but I can't be a physics teacher. Okay, I hope that makes sense. Now next, in a group of 20 language teachers, F is the set of teachers who teach French and S is the set of teachers who teach Spanish. Now it's given that the number of French teachers is 16 and the number of Spanish teachers is 10. Just want to point out to you guys once that this little n here means number. So number of French teachers, number of Spanish teachers, right? Okay, now it's asking us to state the maximum and minimum possible values of the number of F intersecting S and F union S. Okay, one thing I find it really useful to do in these kind of questions is to just sketch out a simple Venn diagram just to illustrate what's actually going on. And I'd actually like to apologize in advance for my absolutely terrible drawing, but okay, that should do. There we go. Yeah. So it's given that the number of French teachers is 16, number of Spanish teachers is 10. Okay. So first thing we want to do, let's start by finding the maximum possible value of the number of F intersecting S. Okay. Now the way we do this is we have to consider different kinds of what do you say, like ideas, right? In the sense that how can I maximize the number of teachers who are both French and Spanish teachers? And you have to think a little outside the box for this one because the answer is this should be 10 here. And why? Well, that's because let's consider all the Spanish teachers to also be French teachers, right? That means that's 0 there and 6 over here. Why will that give us the highest possible value for the intersection? That's because we know that we have to have 10 Spanish teachers, no more, no less. If we try to increase the number of people in the intersection region, that would, well, it would not work because it would make this whole set false. Since the number of Spanish teachers here would have to be -1, and you can't have negative Spanish teachers. So we have to have 10 in the intersection region, right? Because we're considering all the Spanish teachers to also be French teachers, and that's the maximum possible value we can have for the intersection. Let's consider the minimum now for the number of F intersecting S. Okay, for this, there is a little formula kind of thing you can do. So to find it, you can do the number of French teachers, since it's a greater number, minus the number of Spanish teachers, right? So you can do 16 minus 10. And what's 16 minus 10? Well, that's 6, right? Oops, sorry about that. I'll just draw that back for you guys. So 16 minus 10 is 6. So let's put 6 into this intersection region, and that will give us the lowest possible value, right? Let's fill in the rest of it. So that becomes 4, and that becomes 10. Yeah, there we go. So why does that give us the smallest possible value of the intersection? Well, we can't decrease the intersection region anymore here, because once again that would give us a false set, or that would tamper with the results. So every time you see a question like this, always use this formula here. Number of the larger number minus the smaller number, and that's for the minimum, right? So the minimum here would be 6. Okay, now let's look at the unions. Let's once again start with maximum, then move on to minimum. Okay, so how can we get the maximum possible value for F union S? Well, once again, it's telling us we've got 20 language teachers. Now let's suppose all our language teachers are French and Spanish teachers, right? That would mean the maximum is 20, or rather, we're saying E, which is all the teachers in the set, is 20. And we're also saying that these 20 language teachers, every single one of them are French and Spanish teachers. So all of them fall under the set of F union S. And if that's the case, well, we can't have any more teachers because we'd only have 20 language teachers, right? So the maximum possible value of F union S, the French and Spanish teachers combined, is 20. Let's now look at the minimum possible value for F union S. Okay, and what we want to do over here is kind of the opposite actually. So I'm just gonna rub this out real quick. Yeah, there we go. Okay, so how can we find the minimum? Okay, well, the answer is actually, it's not too hard actually. Let's once again suppose that we have the maximum number of intersecting French and Spanish teachers, right? So let's suppose we have 10 of them. That would give us 6 over here, right? And 0 here. So 10 plus 6, 16, right? So over here, if we consider this situation, the number of F union S, sorry, is 16. So F union S is 16. And that actually is, in fact, the minimum possible value we can have. And I'm going to show you why by kind of disproving it using another example. So let's suppose we had the minimum possible value for the intersection. Let's suppose we had 6 over here. That would mean we have to have 4 Spanish teachers and 10 uh, French teachers, right? 10 plus 6, 16 plus 4, 20. 20 language teachers. That would give us the maximum possible value of F union S. So as this intersection region increases, the union decreases, right? It's really interesting. So As the maximum possible value for the intersection increases, the maximum possible value for the union, it subsequently decreases. And similarly, as a minimum possible value, as it goes down, so as the value of intersecting S decreases, the maximum possible value for F union S actually increases. So that's one way you can actually consider these kind of problems. Once you find this, just take these values and plug them into the Venn diagram, and you can just find them because these are opposites, right? As in they work inversely to each other. Now, I hope that is making sense to you guys. It is a little hard to grasp at first, but do some exam questions and you'll get it eventually. Okay, let's move on to the next question now. The diagram above shows a universal set E and three sets A, B, and C. So it asks us to copy the above diagram and shade the region representing A intersecting C complement union B. Well, we've just got the diagram here, so there really is no need to copy it. So it's asking us to represent A intersecting C complement union B. Wow, I can't draw a straight line today. Okay, so let's start by considering this symbol here, the union. Okay, what does union actually mean, right? Well, in simple terms, it just literally means everything, every single thing in both sets. There we go, right? Okay, so immediately as we have this union, we want to consider everything in set B and everything in set A intersecting C complement. Let's start with the easy one, right? So everything in set B. So let's just go ahead and shade everything in set B. What? Okay, yeah, sorry. Yeah, there we go. And that's that done. So everything in set B shaded already. Okay, so that's already one half of our representation on the Venn diagram finished. So let's consider this part now. So the way I like to view complements, which essentially just means not. So just complement just means not basically. The way I like to view them is by actually taking my fist or my thumb and covering the set that I don't want. So here I would look at this as A intersecting not C. So I just take my finger or my fist, just cover the C set completely. And where does that intersect A? Well, it intersects A at this region here, doesn't it? All of this region. Not touching C, but then everything else. And all of it because of the union. And there we go. That's it. That's the region we're looking for. We've considered this bit done, this bit done. So we're done with this. Okay. Now, it asks us to express in set notation the set represented by the shaded region in the diagram above. Okay, let's just consider this for a second. We see that there's a little intersection region between A and C, but nothing with B. So B is completely out of the picture essentially. And how do we represent that? Well, we just said initially that a complement represents not. So here we're just saying not B, right? And its intersection with A. Where does not B intersect A? Well, all over here, right? This whole region. So if I was to show you not B intersecting A, that would be this whole region. We know this region here is intersecting with C, isn't it? So we know that must be our inequality that will, sorry, that must be the expression we're looking for, right? So I'm just going to go ahead and write it. We're looking for B complement intersecting with A and this set's intersection with C. You could also write it A intersecting B complement intersecting C, it doesn't really matter. And that will give us this region over here. So not B, its intersection with A, this whole bit, and its intersection with C, this bit. Okay, done. Now this one is not too hard actually. It asks us to show by means of two diagrams that the set X union Y complement is not the same as the set X in is X complement union Y complement. So let's start by doing X union Y complement. So let's label this set X, let's label this set Y. So if we did have this whole, if we did have X union Y, that would give us this whole region shaded in, wouldn't it? All of this, right? But then we don't want X union Y. It's saying everything except X union Y or X union Y complement. And what would that give us? Well, if we took our two of our fingers and completely covered X union Y, what would we get? What would we be left with? Only this background region, right? Only this. Not actually touching X union Y, but just the background region. All of this. Yeah, there we go. Okay, there we go. And now let's consider the set X complement union Y complement. Okay, let's add X there, let's add Y there. So X complement union Y complement. Okay, how do we want to represent this? Well, let's start by looking at X complement. Since it's union, we want everything in X complement and everything in Y complement. So let's look at X complement first. Take your finger, your thumb, your fist, whatever, and cover X completely. Right? What are we left with? We're asking for, we have a union, right? So we want everything that's not in X complement. Sorry, everything that's not in X. So we'll go ahead and shade everything that's not in X. And that'll give us this whole bit, including the background and this Y region here. Everything except X, right? And now if we want to shade in Y complement, it's pretty similar. Since we already have the background, all we need to shade in is this region over here. And that gives us everything in X complement and everything in Y complement, right? And pretty obviously, this set here is not the same as this set, right? They're not equal to each other. So as a conclusion, I would just write three dots and shown. Okay, that's all. Let's now move on to the next question. So it asks us to shade the region corresponding to the set given below each Venn diagram. Okay, so we start with A union B intersecting C complement. Okay, simple enough. So everything in A and everything in B intersecting everything not in C. That has to be this region over here, right? All of this. Yeah, that's all. Easy one. Now, A union B union C and the complement of all of it. This is also not too hard. So if we consider A union B union C, it's all of these circles and all the intersections, everything except the background. But since we have a complement here, we don't want this region here, so it's just the background bit. Okay. Now lastly, we have A intersecting B union B intersecting C union C intersecting A. Okay. This one looks a little tricky at first, but then just bear with me. It shouldn't be too hard. So let's start with, once again, the union. It means everything. So shade in everything. So A intersecting B. Let's start by shading that in. Okay, there we go. I'm not going to include this bit over here since that includes the C, and we're not really sure if the C comes in yet or not. And let's now go ahead and do B intersecting C and C intersecting A. Okay, done. But then hang on a second, this can't be right, right? It's asking us for the union. So that must mean that A intersecting B intersecting C also comes under here somewhere. So we've missed out this bit, so it does come under this set. So it's this whole region over here that we're looking for. Okay. Now given that P, the set P is such that tan P is equal to 1 for 0 degrees to 540 degrees, it asks us to find the number of P's, and this is for 1 mark. Okay. I hope you know your basic trigonometry. If not, you might want to just brush up on your trigonometry before you attempt this question. So the first thing we want to do, it's telling us tan P is 1, right? So let's find out what P is. How do we do that? Well, P is arctan or inverse tan of 1, and that, if you just take out your calculator and try that out, that will give you 45 degrees. That's the first value we get, the principal value. Now, I wonder if you guys are familiar with the cast diagram. It's actually a really useful way to represent and find angles um, with the trigonometric ratios. A stands for all, S stands for sine, T stands for tan, and C stands for cos, right? But in fact, we don't actually need the cast diagram yet, or in this whole question, actually, since we're looking for tan. And one thing that's really unique about the tan graph, I'm going to draw an absolutely terrible tan graph here. Yeah, one thing that's really unique about the tan graph is that angles that correspond to the same value are only 180 degrees apart, right? So if you want to find the next value between 0 degrees and 540 degrees of tan to the negative 1 of 1, then all you have to do is 45 plus 180 gives you 225, right? So that's our next value. Let's go ahead and write down the set of P. So we've got 45 there. We've got 225. And let's add 180 degrees to that as well. We've also got 405. Now let's try adding 180 degrees to 405. We get 585. Well, unfortunately, that's greater than 540, so we can't include that. So we stop our set over there. Okay, that's done. And it asks us to find the number of P. Let's not forget the question focus. So the number of P, well, just count how many elements are there. 1, 2, 3. So number of 3, P is 3, and we're done. Last question before I sign off. The universal set E and the sets A and B are shown in the Venn diagram below such that the number of A is 15, number of B is 20, and the number of A prime or A complement intersecting B is equal to 6. It also tells us that the number of E, the universal set, is 30. So in the Venn diagram below, insert the number of elements in the set represented by each of the 4 regions. Okay, this is a little more fun. Good break from the boring questions before this. Okay, so let's start with what we know. I would start by going with the most obvious piece of information, this. The number of A prime intersecting B is 6. So let's cover A with our finger or our thumb, and that leaves us with this region and the background. Where does that intersect B? Well, only in this region over here. So this must have 6 elements. Okay. Now, number of B in total is 20. We've got 6 elements here. So how many should be in the intersection? Well, that's 20 minus 6, which is 14. And now for A, 15 minus 14. So that's just 1. And we're not done yet. We've been told that everything, the number of elements in the universal set is 30, right? So let's count up how much we already have now. We've got 1 plus 14 is 15 plus 6, 21 elements. If we've got 21 elements, that means there have to be 30 minus 21, which is 9 elements outside. And now we're done. Okay, last question. In the Venn diagram below, shade the region that represents P union Q intersecting R complement. Once again, pretty easy question. So P union Q by itself is just this region and all of it. But we're completely ignoring the R region. So take your thumb, your fist, or whatever, and just place it on the R region. Ignore any intersections with R. And what will that give us? Well, that'll give us this region over here, all of this. Okay, there we go. And I believe that is all for this video. Thank you so much for watching. Please do comment below if you have a question or you'd like to communicate with me about something. And if you enjoy this video, do go ahead and subscribe. Yeah, thank you. See you later.